A day in the life of Chelsea Garcia. So, my name is Chelsea Garcia. I'm a first year PhD student in the Department of Nutritional Sciences, and I work under Dr. Christopher Blesso, and I have worked in his lab for about 5 years now. One of our main research interests are in milk polar lipids. Milk polar lipids can be comprised of either phospholipids or sphingolipids. We have already shown in our lab that supplementation of dietary sphingolipids can reduce inflammation, decrease fat and cholesterol absorption, and modulate the gut microbiome in mice fed a high-fat diet. Here is a common study design where mice are randomized into different groups and then given a special diet. This can be a control or the same diet including our bioactive compounds of interest. At the end of the study, the mice are humanely sacrificed and all samples collected will be used for further biochemical analyses.
So here I am making the diet for the mice, so this is what they're going to eat. I am just measuring out all of my ingredients. I use beakers and I tare them on the scale first, or I use a weight boat, and then I measure out whatever I need to measure out. A lot of the times I need to measure out sugar or fiber or cholesterol, and then I mix everything in a stand mixer, and then I form little balls like cookie dough and wrap them in plastic wrap, and then I put tape on them, seal them up, and label them. Once we finish the study and sacrifice the animals, we isolate RNA from various organs that we can then make into cDNA and use for PCR to look at gene expression. Right now, I'm reading RNA concentrations of different samples that I've isolated RNA from. And first, I disinfected my workspace and all of my instruments and my hands. And then I made sure that all of the samples have thawed completely on ice and have vortexed them so they're all homogenized. And then I'm using this Take 3 microplate reader to read the RNA concentrations using the software provided. So once I walk it over and put it in the machine, then I read the plate and I'll show you what the results are.
This is the Excel file that gets exported out of that Gen 5 provided software. And then you can see here that this is the concentration of RNA that we have in our samples. So what we generally do is we put the sample ID, we take the average concentration of the duplicates, and then we can calculate the volume of RNA and water that we're going to need to make cDNA. After isolating RNA, we can then use that to make cDNA, which is what I'm going to be doing next. So first I have to label all the tubes for my samples appropriately, and then afterwards I put in all the reagents and water and RNA necessary to make cDNA. Lastly, we are going to use our cDNA to perform quantitative reverse transcription PCR to look at gene expression. So first I have to disinfect everything, then I have to make my master mix with the cyber and the forward and reverse primers that are going to pick up your gene of interest.
Once I'm done plating the master mix in each sample,
I seal the plate with the sticker, I put it in the machine, and then I prepare myself for any other assay that I have to do that day. And that's it. Thanks for watching.